Okay, in this video, we're going to consider resistance. As the name suggests, resistance is all about how difficult it makes it for the current to flow. So put simply, we can state this about the relationship between current and resistance. The larger the resistance in your circuit, the lower the current, and the smaller resistance in your circuit, the higher the current. Measure our resistance in ohms. Let's consider what happens to our resistance in series circuits. In series, as you add more components to your circuit, your resistance increases. Simple. Let's have a look at an example. Let's say you have two bulbs which both have a resistance of 4 ohms, and you have a resistor with a resistance of 8 ohms in series with each other. How do I find the total resistance of my circuit? Well, you simply add them together. 4 plus 8 plus 4 is 16 ohms. The more stuff I add, the more the resistance increases, and the lower the current gets. Parallel circuits are a little more complicated. Let us say that you start with the following circuit. A cell and a bulb with a resistance of 4 ohms. Now I'm going to add a branch in parallel. The resistance of the circuit has dropped. Now that's really counterintuitive. The more stuff you're adding in parallel, the more the resistance is dropping. So it might be helpful to consider our postmen again. If you haven't seen my previous videos, my postmen are my coulombs in my circuit and the wires are the roads that they are driving around. Now, in a parallel circuit where you have multiple branches, it's like your postmen have more routes that they could take. And because they have more roads that they can travel down, it is easier for them to flow. So in my original circuit, I had 2 amps flowing through my circuit. Now in my new circuit, I can have those 2 amps flowing down both of the branches. And because of my parallel rules that we visited in a previous video, current into the junction equals current out of the junction. So 2 plus 2 is equal to 4. The total current going through my circuit has increased because the resistance of my circuit has decreased. The next section of this video is a little bit of an extension. So the resistance actually helps me to decide how my current is going to split, or more likely in what ratio my current is going to split in parallel. Let's imagine I have the following circuit. I've got 2 bulbs in my top branch, both with a resistance of 4 ohms, and I've got 1 bulb in my bottom branch with a resistance of 4 ohms. Now, because I have double the resistance in my top branch compared to my bottom branch, I am going to have half the current in my top branch when I compare it to the current in my bottom branch. So in this circuit, as I have a total of 3 amps flowing into my junction, my current's no longer going to split evenly. There's going to be 1 amp through the top branch and 2 amps through the bottom branch. It's twice as easy for my current to flow through the bottom branch that has half the resistance. Okay, hopefully you found that helpful. Please make sure you download the notes and click on the next video to continue learning about electricity.